cambiar vidas,
change lives,
change organizations,
change
दुनिया में
organizations,
बदलाव.
Change the world.
Glad to be here. I'm Brian Carey. So the way I've structured my talk is I've kind of got a mixture of smart city overview. I'm going to talk a little bit about when we say smart city, how we classify what a smart city is. Give a little quick overview. I think you guys talked about this yesterday, but some lessons learned on some of the smart cities to date. Specifically, I'll talk about some learnings at Masdar. We've got a big group in the Middle East that was pretty involved with that project, so I want to share some of the lessons learned from that. And then I'll kind of go through some different segments that will help enable smart cities down the road and talk about what technologies are taking place today, what's in the future, what are some of the roadblocks, and what are some of the key success factors that need to happen, some of these companies need to do in order to be successful. So when PwC thinks about a smart city, we see it as kind of the whole distribution network that connects residential, commercial users, as well as electric vehicles and energy production or connection to the grid, and really optimizes that. So in the residential space, it's managing energy consumption. You've got some distributed generation, as well as electrical vehicle charging. You've got somewhat similar types of activities in the commercial arena. However, you do have off-peak generation that has the potential to be stored, as well as things are much, much larger. You've also got infrastructure to support parking of electric vehicles that's at a lot larger scale than residential. And then in the distribution network, really the connection to the grid, some of the key features are much more two-way communication, information flow, very different than the one-way that's happened in the past, and an ability to really better monitor and manage your network, identify faults, speed up recovery, so that you've got much more stability in the grid. And those are all sort of enabled by a couple of different technologies. Demand response is something that sort of connects the grid to residential and helps manage peak loads a little bit better. And then storage and distributed generation are something that help balance peak demand periods and eliminate some of the requirements from the grid. Just a quick overview. Smart cities are not something new. I mean, this is I think from last year, 2010, and as of then, there was a number of different smart cities that had been announced. So they're well on their way up in terms of number and size. I guess the key point is that if folks were curious if they're here yet, they've arrived. So I mean, they're starting to develop and make a presence, and we're starting to learn from them. So just a couple of quick lessons from Masdar. We had some teams, PwC did, actually my legacy PRTM team that before the PwC merger that was involved with some activities at Masdar. I'll touch on these quickly because I know you guys are probably more interested in some of the next generation stuff. Just a few things that we learned just from our involvement. You really need to have a system engineering approach. You can't sort of look at things from an architecture or an engineering perspective. It's very required that it's very mandatory that those groups work together, and that you've got kind of regular reviews for those groups, and one person isn't marching in another direction to help eliminate rework. They had a very strong group leading the overall initiative, which is great, but ultimately you need very cross-functional organization that is going to work collaboratively to help coordinate all the complexities associated with a smart city. Everything really has to be looked at in view of life cycle costs. Are the tenants, are the users, is everyone putting in place hardware capabilities, infrastructure that's going to be net cheaper than kind of business as usual? Very critical to maintain a portfolio of options. Smart cities aren't rolled out overnight. You can't sort of choose a bunch of suppliers in the beginning, say this is the suppliers for the next 4 or 5 years, because there's so much innovation and so much change in terms of technology and capability and cost. It's important to have really more of a portfolio of different hardware, softwares that you're using when you're kind of coordinating deployment of technology. Very important to build a brand. Masdar did a great job of really generating PR, raising awareness, and what that did is it brought a lot of new innovative ideas to the table during design. And had they not really got the publicity that they achieved, it would have been hard to get some access or just even know about some of that leading technology. Building an ecosystem. There's so many public-private partnerships that you need in order to coordinate, integrate policy, development, make sure everyone's on board, all the stakeholders are aligned, to really to build credibility. If you don't have that sort of from the external view, the visibility, and people don't think that there's a lot of collaboration, coordination going on, it's hard to be successful. And the final thing is, you really have to vet your technologies before you use them. Especially in these early stages, initial reaction, initial perceptions are important. You've got to run your technologies through a kind of similar environment as you run through testing processes. The middle of Dubai is very different than a climate in California, for example. So you've got to really do the right sort of testing and vetting of your technologies in a typical environment where you want to deploy them before you roll them out. So just a couple of different learnings that we had from Masdar. Be more than happy to talk about some of these things if you guys are interested offline. So moving into some of the technology, thought I'd ask a question just to see what folks think, or see how much people know about energy consumption. So in the US, well, I guess, why don't we get a raise of hands here? Buildings count for what % of energy use? 10%? 30? 50? 70? 70 in the US. So cities, the movement to urban environment, buildings, the deployment of new technology to drive reduction of energy consumption in buildings is really going to be a critical part of our ability to manage energy consumption, usage, balance, demand and supply, et cetera, going down the road. So what I'm going to talk through today is I've broken up my talk into five different topics. I'll talk about smart grid, smart buildings, with a little more focus on sort of the distributed automation piece. So kind of ignoring transmission, so everything from from a substation down to delivering the power to the users. I'll talk about solar PV. I'll discuss storage. Talk about LED lighting and its ramp that it's going through right now, as well as electric vehicles and infrastructure. So smart grid. Most of the technology that's been in place today, or what's sort of driven deployment of smart grid, has been smart meters. Everyone's aware of Silver Spring and LNG and GE, some of the bigger players in that space. Energy efficiency has been a pretty popular sort of, I don't know if I'd call it a technology, but there's some technology to support energy efficiency, as well as kind of upgrades of switches. Where we see things going down the road in the technology is, much more integrated building energy management. Companies like Sky Energy is an example that has some pretty cool technology that manages energy controls in buildings, as well as a lot tighter interconnection and automation between switches, meters, and things that are in the house. So it's some of the technologies there today. It just hasn't reached the mass adoption from a deployment standpoint. Couple of kind of quick case studies. You know, who are some of the leaders? I'm sure most folks here are aware of these. You know, utility smart meters have sort of went through a big ramp in the U.S. You know, over the last 3 years. Encore utility in Texas is probably a good example of who did the best job in terms of engaging the customer. You know, they did a lot of proactive outreach to customers, deployed about 2 million meters, and actually drove through deployment of the meters, visibility to energy consumption. They drove a 33% reduction in power in 2011 through the deployment of their AMI program. So, Encore, Texas, ONCOR. Another big area is distribution equipment upgrades. So a couple of utilities listed there. I think one of the probably smaller but more interesting case studies there is EPB, utility in Chattanooga. So they implemented 1,000 automated switches for their substation that were supported by a SCADA network. They automated 80% of their high voltage transmission, and it's all the automation that they've got in terms of transmission and distribution is all interconnected with fiber. So one of the kind of leading examples of a company that's really taken automation in terms of to the next level when it comes to distribution. 2015, a couple of these are kind of projects that are in process that are setting the stage, I think, for what things will look like down the road. Pecan Street project. How many people are familiar with Pecan Street project? Not too many. So it's a consortium in Austin, Texas, that was supported by Austin Energy, NREL, the National Renewables Laboratory, the EDF Fund, and others to help set the standard for, you know, what does the future community need to look like. So it's about 1,000 homes, and they got the users to really set the standards and the requirements for what this kind of smart city needs to look like. And when I say smart city, it's everything. I mean, the EV, renewables, building energy management, LEDs, all of that stuff. But pretty cool. I think the companies that I mentioned put forward $15 million. It got matched by another fund, and they're in the process of deploying that in Austin. So if you have some time, read up on that. It's a pretty interesting case study of how they brought all the technologies together, but also how they really worked with the consumers to help define the standards. You know, and they actually set, which is really interesting, what their utility rate should be. You know, they said we think in this environment our rate should be X, and the Austin Energy complied and kind of set that, followed what their recommendations were. Let's see, Hydro One, pretty good installations ongoing. Trilliant is the kind of the backbone to support that, and then the final thing is automated demand response. I think most people know what demand response is. I would assume. You know, this is really what a lot of demand response today is pretty manual. It's you know, Internoc calls their customer and says, "Hey, go turn off that load so that I can. I got a call from the ISO. I need to balance out my load." Automated is really real-time activation automation of all those controls. Kind of the next step from that is microgrids. You know, there's a lot of cool stuff going on in the kind of advanced demand response microgrid space. Companies like these are more software companies. Veridity, Embala, Infotility, Power Analytics are all kind of software companies that are getting into or have solutions to support the automated demand response space. So just to touch on a couple sort of lesson learned and what things look like in the future for smart grid. PG&E being a good example, it's important to engage your stakeholders as you're rolling out solutions so that you don't have backlash and they're full aware of what you're doing. And as I talked a little bit from the Masdar example, you've got to have a portfolio of options as you're rolling out these technologies and really look at life cycle costs versus the benefits that you're giving to the users. Deployment challenges. I think the main thing that's going to happen here is there's going to be companies start to insert themselves in between the utilities and the user, and you're going to start to see this disintermediary type of activity, where people come up with new business models, and it's going to require new infrastructure, new regulation. I think that whole interconnection point between utilities and consumers is going to be pretty dynamic, especially in companies like China, where there's kind of a government-owned entity and a user. As new businesses try to insert themselves in that to help consumers better manage energy, it'll be quite interesting. So going forward in this space, what's important, you've really got to spend the time and effort to prove the benefits of your technology with your customers before you start rolling it out. And you've got to ultimately, plan for flexibility. Technologies are changing. Standards aren't quite where they need to be right now. So you've got to, if you're an equipment or a hardware, software supplier to this space, really plan for flexibility as you plan your roadmap going forward. So EVs, what's going on in the EV space? So I think most people here are probably aware that there's a variety of different electrification vehicles out there, everything from kind of light hybrids to pure hybrids to plug-in hybrids to pure EVs. A couple of different battery technologies that are still pricey. Going forward, I think a couple of things that will emerge or really start to ramp up in terms of making an impact in the EV space is fast charging technology. So all the big OEMs, BMW, Audi, GM, Nissan, all those guys have finally agreed on some good standards for the next generation of fast charging technology. In the US, that should start to show up in the dealerships next year. Europe is a little more conservative in terms of kind of estimating when it's going to be deployed completely in their region. And then lithium-ion batteries, there's a lot of effort, there's a lot of development going into driving down the cost of lithium-ion batteries. I don't think they'll be quite optimized by 2015, but we're trying to get there. There's still going to be a long tail after that to continue to drive down costs. But you'll start to see some companies making some headway in the lithium-ion battery space. A couple case studies touch on where within cities EVs are starting to make an impact. This company in Paris is an EV sharing program that has I think the number is 5,000 or 3,000 cars and 1,000 subscribers. Expect by the end of this year to have 15,000 subscribers. It's a pretty interesting program. EV Project US is a kind of a consortium of 12 cities, mostly in kind of the Midwest, Tennessee, as well as the West Coast, where they're doing a good job to try to understand EV usage, habits, routes, kind of the learnings from the whole EV space, so they can try to take those learnings and build them back into their products and infrastructure rollout that they're doing. Beijing EV Bus Pilot, they converted a number of traditional gas stations to also charging stations, have rolled out about 50 or so buses and expect to do another 400 this year, so pretty interesting. On the case study side, Source London is a program that's that's rolling out a bunch of charging stations. So you go online, you sign up, you pay £100. You can then use any of their, right now they've got 1,300 charging stations around the city of London, and you can charge your car. Pretty interesting solution there for charging. I talked a little bit about Pecan Street. So in the EV space, lessons learned, I think the car manufacturers quickly realized that fleets are a very important part of kind of the growth of EVs. It's like 500 million cars if you add up the top 50 fleets in the US. But they've got the right sort of, they look at things the right way to help drive adoption of EVs. They look at total cost of ownership. You know, aesthetics isn't that important to them like it is for typical users. They have high utilization. They tend to have sort of standard routes. You know, you bring the cars back a lot of the times to its central location, so it's easy to put in charging. We got to have incentives to drive adoption of EVs as well. Not only the government state incentives, but everything from you know, charging at your retail outlet to HOV lanes, et cetera. So there's got to be the right sort of rationale and reasoning and drivers to help adopt EVs. So going forward, what's going to be some of the challenges? Continued you know, customer acceptance concerns. So range anxiety is going to continue to be an issue. We've got to have more integration kind of across the ecosystem, from cars to batteries to the grid to government. You know, those folks need to work together to make sure that there's alignment on standards and roadmap and programs. And then charging for folks who don't have garages. So if you live in a city, it's a little challenging to charge a car. So how would you even consider buying an electric vehicle? So going forward, what's important? So the car manufacturers really need to understand all the use cases. So for each type of customer, how often do they drive? How long do they drive? And try to match their kind of portfolio, their roadmap of products. You need to, that's 5 minutes left, right? Okay. Identify partners to deploy charging infrastructure. And utilities need to be involved in this whole process. So let me touch on PV real fast. You know, today it's crystalline silicon, thin film, and microinverters. You know, down the road, what are some of the new technologies that are coming? You know, building integrated PV, integrated AC modules. Actually, putting the inverter into the module is a new technology. Array Power is a company that's got some pretty neat technology there, as well as integration of solar into the grid, being able to manage ups and downs of voltage frequency. San Diego is probably one of the leading companies that's really driven adoption of PV and renewables. And then going down the road, this consortium here in Europe has set some pretty aggressive standards for building energy consumption, and you know, they've actually set some levels of how much renewables need to be deployed as a part of that. So lessons learned. There's got to be a lot of collaboration across the value chain as companies are bringing new products and technologies to market. It's not really happening today like it should. And then I talked a little bit about the future. You know, this grid integration is going to be critical for PV deployment. Challenges, you know, PV creates these irregular variations, so we've got to be able to challenge that. A big challenge also is some of the, at least in the US, permitting, installation, some of those sort of things aren't standardized. So the cost in residential and commercial solar PV are much higher than they should be. They're actually like twice the cost that they are in Germany. So a lot of these key success factors down at the bottom are all about how do we drive down not the panel cost, but more the other hardware, the installation, the customer acquisition, some of the permitting costs. we need to drive down those costs to help make solar more affordable. And then I think in the long term, the residential, the commercial markets have much more opportunity relative to utility scale, especially in the U.S. So should be pretty interesting. So I've got not much time. I've got a storage slide and an LED lighting slide. Any particular preference on what you guys are interested in hearing about? LED? Storage? Okay. And I can share it. I think this is available so you guys can look through it on your own. So, traditional technology and storage, pumped hydro, batteries. Where are things going down the road? Lithium ion is really going to scale. You're going to see a lot of different applications for it, both in EVs as well as grid-scale storage. Ultra capacitors, Maxwell is a kind of leading company there. Should be ability to quickly feed a bunch of power at one time, as well as compressed energy storage, which has a lot of volume, but not as much ability to deliver a lot of power at one time. I think folks are probably aware of some of the things that exist today. So dams kind of provide hydro, provide base load capacity, as well as grid scale batteries. Down the road, it's sort of a theme. All of these things that we've talked about, all these different technologies, they're all kind of merging. So renewables will start to integrate with storage. Storage companies need to work with with renewables folks to come up with business models to figure out how they can better manage power quality and, when they're generating power, save it to a time when it's required. Integration with EVs. You probably heard a little bit about the talk of EVs actually being part of storage for the grid. I think it's still a little bit off some of the conversations we've had with executives at auto companies. Don't see it in quite the near future, but there's a lot of storage out there once you look at hundreds of thousands electric vehicles on the road. And then distributed demand response. So storage is going to drive adoption or enablement of more automated demand response models. It's going to allow microgrids to really emerge and develop. And the cool part about that is once you've got a microgrid, you're able to really compete in the energy market. So if you can somehow generate power when it's low cost and store it and sell it back to the grid when it's cheap, there's a lot of opportunity to make money there. Lessons learned, technology, the best technology doesn't always win. There's regulation, there's complexity in terms of integration. So even promising business models don't really turn out the way that we want. Going forward, the biggest challenge for solar is for storage. It's really hard to put a price on it. You can go call the local solar city and find out what a solar module costs, but it's really hard to value storage. You know how much it costs to make, but it's hard to put a price on it. The public utility commissions don't know how to really develop a rate case for it because it's difficult to really estimate the value of it. So the companies in the space really need to kind of monitor price signals and try to understand when is the time where it's going to take off. So going forward, I think these are some of the things that we talked about. Battery folks, storage folks need to work with regulators to clearly communicate the value that they bring, and they also need to be working with the renewables companies and the utilities to come up with solution offerings, business models that are going to be appealing to the end user, be it residential or commercial.
Cambiar vidas,
Change lives.
change organizations,
Change
दुनिया में बदलाव.
Change the world.